All right, so in this video, we're going to be looking at finding the turning point and the interval of increase and decrease here for a specific function. So I've already got it graphed over here, and I kind of recommend that you do this for each of these. It's going to make finding these a little bit more straightforward. So y equals, and we're going to graph this. So alpha y equals to make our fraction, or you could just use 0.5. X squared minus x plus 3, and then zoom standard. Make sure we're all starting off on the same page here. All right, so that's the picture, and this is our turning point. We need to find the x and the y value at that spot. So remember, for quadratics, this is just called the vertex, and we're just going to be finding the minimum in this case. So go to the calc menu, so second trace, and then here it's a minimum. All right, it's asking for us to get to the left of the minimum. So as long as we are somewhere to the left of that x value there, enter. And the right value, get to the right side of it, press enter, and then guess. You can press enter again. All right, so 99999. So I'm going to label this thing. This is a 1, 2.5. All right, so that's the coordinates of that vertex. All right, now for our turning point, so we can see this thing is falling. So from negative infinity until it gets to right here, this graph, the y values are actually falling. So positive 1, the x value there. All right, I'm zooming there. All right, that 1, that is our x coordinate of our vertex, or in this case, that's going to be our turning point. So the turning point is x equals 1. Earlier I talked about relative min or relative max. For quadratics, this actually, it is considered a relative minimum, but you could also call this just a flat out minimum. All right, so I'll call it a relative minimum here, but it has a relative minimum at the y value of the turning point. So 2.5. Okay. And then we're going to use our turning point here to create our interval of increase and decrease. So increasing, so this thing, the y values are getting bigger as it goes to the right, and this thing's going uphill. And we're going to use our turning point. We're going to look at the x values. So it is increasing from 1 to, oh, that's a terrible infinity. From 1 to infinity. I notice the parentheses here because it doesn't increase or decrease at 1, so I don't include it. Parentheses there. If we were doing that in algebraic notation, it would be all the x values that are bigger than 1. All right, so for all the x values that are bigger than 1, this thing is going uphill. It's increasing. All right, the interval of decrease, it's going to be the same idea, but it's back here. So from negative infinity until it gets to 1, this thing is falling. So that's negative infinity to 1. Right. And then or, I guess, I should have put that there. Or for the algebraic notation, it would be all the x values that are less than 1. So for all the x values that come before 1, this thing is falling. All right. It's good. All right.